When they broached the subject to us, we always felt that we could drill it fairly easily. The question was always going to be, can we get casing to bottom? So we spent a lot of time looking at the path of the well and then discussing with our vendors about what we're going to do, how we're going to do it, some of the challenges. The key learning we had was when we went to see that offset operator that had done these and spoke to them, and they really opened our eyes up to about what we were going to do or what we could do, and we pivoted very quickly to redesign the well for, obviously stiffer casing. The challenge for these wells is always getting casing in the ground. Initially, we were going to use a standard 20-pound, 5.5-inch casing, and looking at the modeling that we'd done previously, we knew that that type of casing would run into buckling issues later on in the lateral. Like even on a 3-mile lateral, they run into the casing buckles in the wellbore, and you get into a point of lockup. We were looking at a heavy wall, 5.5, 23 pounds, something that's going to be a little bit heavier and stiffer, and in looking at it, it would go to bottom, but it caused problems because our internal diameter was a lot less than the 20-pound, and that would cause pressure issues with the completion team. So after we met with that offset operator and they recommended 6-inch casing, literally as we were leaving the meeting with that offset operator, we were on the phone with a casing supplier to get casing, 6-inch casing. So a bigger diameter gives us the stiffness we need and the ID that the completion teams need. And then knowing that and knowing the exact friction factors that we were going to see, because we drilled wells here previously, we were easily able to model the casing going in the ground with flotation in it, easy. So we were forced into a synthetic oil-based mud here from the regulators, which it doesn't really matter. But the mud that we needed to have had to be light to help control ECD, and it also had to be thin to help control ECD. But light and thin are problematic with hole cleaning, so we had to balance the properties of the mud and make sure that we were very specific about our mud properties to ensure that we had the right low end rheology and the right low mud weights to keep our ECDs low, and we were able to clean the wellbore actually quite fast. It becomes different because your uncertainties become much greater. And in our case, we were going east-west, which makes the magnetics less accurate. So we actually had to use survey correction as we go to make sure that we were where we thought we were, or as close to we thought we were. So the ellipse of uncertainties get quite large when you're out that far, and especially when you're traveling east and west. So we're using 3 things really. We're using our magnetics to determine where we are in space. We're also using a gamma ray signature to kind of rate that against the gamma ray signatures from vertical wells. So with those 2, we can get a good idea of where we are and reduce our uncertainty. So the geosteering wasn't that bad, and it helps that this part of the Niobrara is not very faulted. So we pretty much locked it in on a plan and drilled ahead. The big part was we hired the right well site leaders. I mean, we used a gentleman that I had met many years ago, somebody that actually taught me how to drill horizontal wells, and he was available. And in talking with him and talking with the drilling team here and our own well site leaders, we basically come with an agreed set of KPIs about what we wanted. We wanted a fast, efficient well in zone, no incidences, and we set those expectations at a spud meeting. This project come together so quick, we didn't have time to do a proper DWAP. So I went to the rig and we had an hour-long spud meeting and really didn't talk about the well at all. We talked about expectations, what we are looking for, connection-wise, people-wise, job functions, cleanliness, and basically, safety, of course, keeping your head on a swivel, watching everybody, and keeping the rig clean. So having a good team to start with and then bringing in the outside vendors like the rig crews and all the third-party people to witness that the well site team, the management team, and the engineering team are all on the same page. It helped everybody get aligned and move forward. The keys to that were, number one, having a very smooth well. We had no major ups or downs, no major hard lefts or right. We drilled on a plan, so it was very smooth. We did a very good job cleaning the wellbore at TD, and we modeled our drag as we drilled. So we not only did we model the wells that we drilled before this to get an idea how the rock is going to interact with the casing, but we also monitored the drag on this well as we drilled. And ironically enough, the last stand that we drilled just as fast as the first stand in the lateral. So we knew that we had a pretty good handle on friction. And as long as we kept the wellbore clean and we modeled our casing run going in, we could see that it was tracking the model perfectly. And we knew really before casing got to bottom that it was gonna go. We had two backup plans. Number one is that if we became obstructed, we would rotate. Because we're floating the casing in, we would not really be able to circulate, but we could rotate. So in the event that we couldn't push the casing in any further, our first step would be to rotate. And the casing we ran has a connection that is obviously rotatable up to a certain torque value. So we set our torque value on the top drive to something less than the maximum, and we would rotate very slowly and try and get this casing in. If we did run into a situation where that didn't work anymore, then the other option would be to burst the flotation disc and circulate and rotate, and that would be how we would get casing to bottom. Plan and get more time than we had. I mean, we had a lot of time to plan the 4-miler, but the last minute change to 6-inch casing really put a wrench in the plan. But it worked out in our case. But the idea here is to have a plan and talk to the other side of the business. Like, drilling the well is easy. Running casing is hard. And cementing it is hard. But when you're done, you also have to leave a wellbore for the completion team to use. So we had some conversations with the completion guys as well to make sure that what we were doing wasn't going to adversely affect what they needed to do later on.